to get started with serverless, which is a best practice, let's go through and document a little bit about serverless and microservices and what's the point and why is this even anything to do with DevOps. Well, to start with, serverless and microservices are DevOps best practices. So DevOps and microservice are closely related together. And part of the reason behind this is that in the old days, let's say from 1970 to even, I would say potentially 2005, something like this. This is, we'll call this pre-cloud era, right? And in this era, people are still hyping these technologies. They're hyping these kind of like monolithic frameworks. And so this is where you hear about web frameworks in particular. And this is I would call this like legacy thinking, right? This is thinking that everything should be this giant monolithic. You'll see that everything has to be a relational database, RDB, plus almost as well a CGI web request model, also templating, and people are using like templates for the server itself is essentially translating JSON data back and forth. So this is all like a legacy way of thinking, and it's really expensive computationally. So we know that it's low efficiency as well, and it also is difficult to debug. Debugging is difficult, and also has lots of security holes, right? So this is really, I think, the old way. The new way, so we'll just say, the modern era, and I would say probably 2010 plus, and maybe even we say 2010 to potentially even, let's just only cover the next 10 years. So we'll say 2030 is this DevOps world. And the DevOps world says, look, all that stuff, hey, it got us to where we're at now, but really there's some big problems. And one of them is that a microservice is a lot easier to maintain in that it does a specialized task. And that's really one of the reasons for a microservice. Also, the complexity is low. So this is really a key component of this. Also, the other thing that's about a lot of these frameworks is that it's almost like a cult where you're caught into this world where everyone has to talk the same language. But a microservice like Flask, for example, really lets you get out of that cult and think for yourself, where you can use this microservice in any environment you want. So Flask, for example, fits really well with potentially any cloud. You could have the same Flask app, and it can be applied, in a container, or it can be applied as maybe a microservice or whatever it is you're building. So I think this is also a big takeaway here, is that less is more in the DevOps world, and also that the runtime should be encapsulated with the microservice. And then further, even Flask in a way is a little bit legacy, although it's a microservice, in that it's really not event driven. And so that's something we'll talk about as well, is that a lot of the Lambda services allow you to, or Google Cloud allow you to respond to an event, which this world is only basically pull based, right? Where you're in a loop and you're just constantly just burning down trees in the forest somewhere to get your server to run, where this can just be waiting for you patiently and not doing things. So this is another, I think, often not talked about problem with this legacy world of web frameworks that everybody's pushing still, surprisingly, is that this is bad for the environment, right? So if we look at the word green, this is horrible, right? We have really inefficient servers that are. We know that the science says that climate change is real. It's not fake, and we have these really expensive servers that are just running for no reason. Where if we built an event-based architecture, the events are a much more specialized way to run. So that's just another thing that's kind of a not necessarily talked about enough. And even if you don't believe in climate change, still, why would you want to pay extra money when you could do an event-based architecture? So I think that's a key takeaway here. So now that we know the architecture of microservices and DevOps and why the legacy world needs to be abandoned, let's dive into a repo here in this serverless cookbook. And in particular, this cookbook has a few different things that we can run. The first one would just be this Marco Polo AWS lambda function. And what I'm going to do here is also do a quick sketch of what the point is with these serverless functions. So I talked about polling, right? And I think the best analogy that I will use, that I typically talk about for what are we building, is events. And again, this is directly in opposition from 1970 to 2005, where the legacy world of web frameworks, the new world is events. And the way events work is that it's much like what would happen in your house in terms of your garage. So we have a house here that's got some windows, and we have a door here, and then inside of this we have a garage, and inside the garage there's, let's say, a light bulb like this. Now think about all the different ways that a light bulb in your garage could be triggered. Well, let's look at one. So one is the door opens, right? So this open event could be, we could subscribe essentially this light bulb to the open event, and then all of a sudden the light bulb turns on, right? So that's one way we could handle this. And just like the example of the really poor performing, legacy architectures of web frameworks, you don't want to just leave your light on in your garage 24/7 just to burn, electricity. Why would you do that? You're going to have a high electricity bill. Instead, why don't you respond to an event, which is the door opens, and then the light bulb triggers, and then the light bulb maybe stays on for like 2 minutes, right? That's a pretty elegant architecture. But that's only one of the events that you can do. The other thing you can do is you can say that you can manually turn it on. Like, why not? Why not also, whenever you want to, you just click the light on. You have to do something in your garage, and then you click it off, right? So that's a second kind of event. And there's even a third kind of an event that you could do, which is a timer, right? Where, and again, this really is something that's very common in the cloud, is you could say, listen, from midnight, to 1 a.m, I want you to turn on just so that it's like a deterrent for burglars. And I want this timer to turn on, and then it'll turn off at 1 a.m. So this is such a more powerful and more efficient approach. So serverless is basically, let's look at all these benefits. It's more powerful. So it's got more power. So we'll say power is greater. We also are, it's more efficient as well, because you're only being charged for when you run it. And also it has the ability to be solve more problems, right? And so it's part of a more complex potential solution that you could build. So there's many benefits to using serverless. So let's now dive, with that kind of background behind us, let's dive into building a function in Lambda. So first I'm going to log into my account here and do my auth really quick. And here we go. Let's go ahead and log in real quick. All right, so In AWS, if you want to run a lambda function, what you can do is just go to lambda. And in fact, now lambda support containers, which is pretty awesome. So look, you can say, look, container image, right? Which is totally awesome. We're going to do one from scratch here, and I'm going to call this Marco 2030 to represent the future of how we should be building services. I'm going to select Python 3.8, and then if I create a function here, the way it works is that it'll give me a IDE that allows me to play around with this particular service. So let's go ahead and create this function, and it creates this version here. I'm going to click on it, and then I can go to the code section here and actually start writing out my function. So it's kind of similar to like a Visual Studio Code development environment. The key takeaway here, though, is this event again. This is where everything happens magically. And if I test it, it's just going to send a JSON payload into this event. But if I want to do a trigger, which if I go to configuration and I go to triggers, this is where you would set up, again, back to the light bulb analogy, right? If I want to set in any of these three kinds of triggers, I would set in the trigger there. So let's see how you would do this. You would go here and you could say, I want to create a web service trigger, or I want to have an IoT device trigger, or I want to do voice recognition trigger, or I want to do, event bridge, right? Which is basically events. I could do a trigger on that. That would be a timer. There's tons of different ways I could trigger this. S3 is another one where you could have a bucket. You put an image into the bucket. It triggers the some kind of event, and then let's say you have Amazon recognition, label the image or something like that. There's lots of ways to trigger. Or SQS is another one where if you wanted to build a high performance processing engine, you could use SQS, and you could just process millions of requests if you needed to. It essentially, SQS handles unlimited amount of traffic. So now that we know that, what I'm going to do is go back to my serverless cookbook here, and I'm going to go to this Marco Polo Lambda and just kind of copy this out. So let's go ahead and put this first part in and put it into the code. And notice what I'm going to do here is I say, if the event has the word, if it has a name in it and it has Marco in it, return back Polo. Otherwise, return back no. And so I'm going to go ahead and deploy this, and then I'm going to click on test. And all you do to create a test is put in a JSON payload here to test it out. So let's go ahead and do this, and we'll say name is Marco. There we go, and we'll invoke it. And when we invoke this thing, you should see that the Polo word appears back, right? So pretty easy to test. And now let's do a bad request. So let's have one called Bob, and then here, if we put Bob in, Bob should get a no. This thing says no. There we go, right? So pretty easy to test a Marco Polo function. And so I like to do the Marco Polo because it's just intuitive, right? I have an event, it has to match. If the event matches, I do one thing. If I don't, I do another thing. So what's neat about this Lambda service is that we can expand it and make it do even a little more magic by a couple different things. One, we can invoke it via the command line. And so I'm going to create a second environment here using Cloud9, which is similar to GitHub Codespaces. I have one, I could either set up a new one or have one already existing. I'm going to create a new one real quick to show how to do it, and we'll just say Lambda Central or something, right, where I want to play around with my Lambda functions. And by default, I believe we can just say everything here. Amazon Linux 2, we'll use Amazon Linux 2. and then we'll say next. There we go. What's nice about these cloud environments, and why I mostly do my code for a particular cloud environment in their cloud shell, is that they already have the tools pre-installed. Like, I'm lazy. I don't want to do a bunch of work, again, like install the SDK and all the stuff. Like it's all ready for me, and it has the right role-based privileges to do these invocations. And so in here, we'll just take a few seconds here, and let's let this scroll. What this will allow us to do is, if I go, while this is spinning up, I'm going to go back to this command, which is this lambda invoke, and I'll show you how cool this is. So here we go. This thing should be ready in a second. Okay, so this thing's woken up now. So why it's awesome, there's a lot of reasons why it's awesome, but one of them is that you have this shell that's got AWS already installed, right? So if I wanted to list my buckets in S3, there you go. I can list my buckets. In this case, though, I want to run this command, which is this. I want to invoke this lambda. Now, I actually want to invoke this one, which is called 2030. So let's go ahead and do this one. We'll just say 2030. And in particular, here, let's look at the different things that I'm going to do. So I'm going to say payload. So I'm going to basically make a payload, and I'm going to put in the word name Marco, and then I'm going to tell this command to capture the output of what happens here, and then just basically print it out. Now I could just take this part out to be lazy initially. Payload lambda invoke Marco Polo function not found Marco Polo. That's weird. I'm not sure why it's not finding this function. I certainly seem to have, maybe I'm misspelling it. Let's try again. And let's see. Did I spell it differently? Maybe I have different caps or something. Oh, Marco. That's why. Okay, so let's go ahead and run this. There we go. So it ran it, and look, it creates this output. And notice that there we go, Polo. And if I want to say, bad out, we can put in the word Bob, and we can actually also test this out. There we go, bad out, and then it has, there we go, no, right? So in my opinion, these lambdas are one of the coolest things you can possibly play around with because of how much awesome things you can do. And this is, again, just an intentionally simple script, but imagine you have at your fingertips basically infinite concurrency, because these lambda functions can run, basically true parallelization, where Python itself, the language, has some real big critical flaws, like you can't do true concurrency with threads. But if you use the cloud itself can do the true concurrency. So you can invoke concurrency from a command line tool, for example. So this particular function here, one of the other things we can take a look at as well is if we go to monitor, now I can actually go to the logs, and I can look at these logs actually right here, which is pretty awesome. And I can see everything that's happening. And if I go to the log stream, it'll show me all the invocations, and I can track down exactly everything that's happening. So here we go. We've got the different statements. I believe that this is the one that I care about here. Now notice that there's no log messages inside of here. It just shows me the invocation. So how would I change that a little bit? In Lambda, the way you would write logs is you just do a print statement. And so what I can do here, this Marco 2030, let's actually tweak it and make it a little smarter. And so I'll go here, and I'll just put a print and say, print this was the raw event, like that. And then I can put in the name of the event. So this is why F strings that we talked about are so powerful, is that they allow you to quickly build like a log statement. And then I could even put line by line some debugging, and I could say prints here, and I could say this event was Marco. We'll just do like that. And then I could do another one below here that said prints, this event was not Marco, like that. So basically it just shows me the execution path of what everything is doing. So we'll deploy this, and if I go back to my environment here, I can execute it, and instead of saying Bob, let's put in Sally, and there we go. It'll overwrite this, and we can look at this. We can see no. And then if I go back to my CloudWatch logs here and we refresh, we should see additional messages here. It'll take a second for them to populate, but we should see basically new messages that have more output inside of them. So this one, here we go. There we go. The event was raw event. This was Sally. This event was not Marco. And we could go iterate from there and there and there. So that's really it in a nutshell, why it's so powerful. Now, what else can we do that's cool? Another thing we can do if we go back to our serverless repo is that there is another thing that's pretty awesome. I guess maybe let's do this before I go away. Is let me grab this and I'll just put this as a file in there as a template, and I'll just say this is a logging version. So we'll just say create new file, AWS lambda Marco logs. There we go. Just so there's another version of this. All right, let's go to this one though, the step function. So what a step function does is it allows you to chain multiple lambdas together and capture the input of one and put the output into another. And so how do you do this? Well, the way you do this is you, and I guess this link here is not working, but basically it's this is the way the code works, is that step by step here, I can just say, here we go, here's the first function, here's the second step function, and I just put these in together. So I'm actually going to build this from scratch. So I'm going to go and grab these together. And I'm going to go to step functions here. And let's go to step functions. And I'm going to say create state machine. And I'm going to just do a regular step function here. And notice that what I can do is just paste it in like this. And notice that this word starts at Marco. This is Marco Polo. And I take one function here. And then after I take the output, I go to the Polo function. And then I do a finish operation. Right? So I'm able to chain together something pretty complex. So let's go ahead to next here. And we'll just call this a Marco Polo step function like this. And now for the role, because we're not calling any APIs, we don't need to do anything tricky. I'm just going to say create new role. And then I'm going to go ahead and create the state machine. Okay, perfect. Now that I've got this, how do I execute it? What I can do is say start execution. And similar in testing is I have to initialize this thing somewhere. And where I'll initialize it is by first, putting inside of here an initial payload. So I'll want to do name here at first, and we'll say name. And inside of this, we'll say, Bob again. Or in fact, actually, let's actually leave this by default. And I'm going to start this execution. And what's going to happen is that this will fail. It'll first, you can see that the input goes here, but it's going to fail because my function here isn't smart enough to handle that. Because if we go back to the lambda that it's calling, notice, let's look at the code for this lambda. It does nothing, right? This lambda code just accepts a payload like that, and if it doesn't match the word name, it just blows up. I don't handle that problem, and it returns back a dictionary, which is name polo. So in this case, it can't work. But what's cool about this is look how I can easily spot every single execution what the state is. So from a DevOps perspective, the fact that I can look at my pipeline step by step and see exactly what's happening really is powerful. And again, this is so different than, let's say, a legacy web framework that doesn't have these tooling. This is really the modern way to develop applications. So let's go ahead and fix this. So let's go ahead and create a new execution. And I'm going to put in the word name here. And then I'm going to put in Bob. So let's see what happens when we put Bob in. Let's go ahead and start this execution. And this should be a little bit different. So it got to Marco. We see what the input is. It says name. So it was at least able to accept it. And then, now it failed a little bit further. So why did it fail? Well, let's look. If we scroll down here, we see that this lambda was successful, but then it entered the Polo lambda. And what does the Polo lambda do? Well, it's expecting that this code will have the word Polo in it. If it doesn't, it then basically returns back a none value, which we don't know how to handle. So we have another problem that we need to fix, right? So it's stuck here. So how do I fix this? Well, let's go back to another execution and let's just fix this. Let's put in Marco, and what will happen is that it will be able to fully pass through all of these phases, because step one is we put in the word Marco, and what does it return back out? It returns back Polo. This one's expecting that you put in the word Polo, and if you put in the word Polo, it will then return back Marco, right? So it just transposes what goes in one function goes out the other, and then it runs a finished operation. And we can see the finished, if we go back here, is if we edit our step function here, that's just that final step, right? Which is it returns back finished. You could put in anything you wanted to do at the end. But this shows how you could build some really cool tools with incredible debugging and logging by using AWS Lambda and or AWS step function. And as I mentioned earlier, maybe as a wrap up here, that what's awesome about the new Lambdas is that you can build them now with Docker containers. So if we go to container image, for example, and I just type in Python container, and I could say enter a image URL. What we could do is just browse a container, and we can see, here we go, it's a Flask demo, or whatever, anything from my Amazon image repository, or I also could check in my own container and overwrite it and build things in here. So there's a lot of new things that are developing with the Lambda functions as well. The last thing I'll show you with this is that if you go to this tab here, AWS Resources, one thing that you can do is you can actually import a function remotely. So if I go to AWS Resources here, click on this, and I go to Marco 230, which is, well, let's just grab this one. I can actually say, double click on it. And what's nice about it is I can later, if I want to, tweak this code and actually add more information to it, right? So that's the other thing that's great about this environment is I can go through here and say, this is an event, put some other, updates to it, prints, and we'll just say f string, this is not a match, right? Something like that. And then what I can do here is I can actually I can save this and actually test it out local. So test out my, let's just refresh this here. Test this out local. So if I right click, I can say run local, and I can test this whole workflow out. So say, name, and we'll just say Marco, what happens here. We're able to run it. Sometimes you have to kind of wake it up. The debugging takes a second to kind of wake up, but there we go. Let's see. The first time I do it, I've noticed sometimes you have to just do it a couple times and then it wakes up. Anyway, I'm not sure why this thing is not invoking. It could be because I used Python 3.8 maybe, but in general, most of the time this works. Oh, there we go. So I must have been waking up. So there we go. And then if I type in Bob here, run this, we can see that this is the other pathway, right? And then if I want to deploy this, I can go through here and right click and do a deploy. And what's awesome is that's pretty quick. And then I go back to my functions here, and here's Marco Polo 9000. Look, I just updated it 4 seconds ago. And then I can test it out, go to this, and test the same piece of code if I wanted to, or even look at the code, and you'll see the code's exact. I added that code there. So really powerful development environment. So that's probably good as a stopping point for this section. Let's move on to a next topic here, which is the GCP cloud. So I covered these two, and in particular, GCP has some pretty cool stuff that we can play around with. And so here's a function that I'll just talk us through real quick, where basically this is a change machine. So what it does is it is a function that will return back the correct amount of change. And so I'm going to invoke this. I mean, I could basically very similar do the same thing on the AWS cloud, but I'll do this one in particular for the GCP cloud. So what I'll do here is open up GCP, and let's go to their cloud functions. And I'm going to log into the console, go to the console. And to build out cloud functions, pretty straightforward actually. You just go to a search bar here and type in functions, and they should pop up in a second once it fully refreshes here. There we go, cloud functions. And inside of cloud functions, in order to create one, create function. And what I can do, that's annoying, is I can say new function name, and we'll just call this DevOps change machine or something like that. and I would decide what region I want to do. And just like any other cloud function, microservice, I could decide what the trigger would be. In this case, the trigger would be a HTTP web service. And I then have the choice as well whether to use authentication or unauthenticated invocations. I think for demos, unauthenticated is the way to go. And so I'll go ahead and say unauthenticated invocations. I'll go ahead and save that. Go to next. And notice that we have a choice here of Python 3.7, 3.8, Node, Java, Go, .NET, all kinds of stuff. So I'm going to select Python 3.8 here. And in particular, you can see this is like a hello world type template that they give you. But in our situation, I already have some code that I'm gonna throw in there. So what I'm gonna do is I'm gonna go to this and I'm gonna put in this payload here, which is kind of a fun little project. Well, what this does is it allows us to pass in a JSON payload that has the word amount in it and some coin amount or some raw amount like $1.34. And then what happens is it gives us the correct change and it kind of prints it out here. So notice that the entry point has to match. So in this case, this is hello world. And also, I think this is an advantage that this interface has a little bit over the Lambda is you can put the installs right here, which is pretty nice. So I'm going to go ahead and say deploy. And what this will do is put this thing into production. And boy, that is really annoying feature of that window popping up a bunch. So basically, once this thing is been deployed, then I can actually start prototyping out this this code here. And the things to look at are testing. And so under the testing window, it really wants that function thing to appear. So under the testing window here, what I would do is put in my payload. And so the payload would look something like this. It would be amount. I'll make this a little bit bigger. This is like conspiring to reset. I don't know, stop popping up. And we go here, we say amounts, and we say $1.34. And in theory, there we go. It gives me a 134. It looks like it's valid JSON. And if I say test, we can scroll down here, and there we go. You can see that it actually returns back the correct amount of change. And if I want to change it to other things, I can go through here and give it, I don't know, $10 and 44 cents, and then test that out and see there's a bunch more quarters, right? So we have a neat little service here to test out, but we can do a lot more as well. And this really shows the power of these cloud-based development environments. If I click on this icon, Activate Cloud Shell, what I can do here is get into testing this function out via a command line tool. And so let's go ahead and take a look at this real quick. And what I can do is look at this command, and this command in particular allows me to invoke it via the Cloud Shell, which is pretty awesome, right? So let's say that I built some kind of a computer vision pipeline and I have it triggered inside of here, or I have some kind of proprietary thing. I can again just treat it like it's a piece of logic that's deployed. It's just waiting for me to run it whenever I want to run it, and I can invoke it via command line tool. To me, this is actually pretty awesome. So I'm going to change this up here, and I'm going to type in DevOps change machine like this. And what we can do is actually invoke this like this. And it will take a second, and it's going to ask me to authenticate, which is fine. So we'll go through here and authenticate. Great. it's going to ask me to do this. I'll go ahead and authenticate. That's fine. Allow this, copy. And now if I go back here, I can enter this auth code. And what we'll do is I can now go through and execute that cloud function. It takes just a second to wake up. There we go. So now I can just, basically go through here and just start tweaking things around, and I can just run it as many times as I want. So I think this is an awesome workflow. That this is an intentionally simple application, but it shows how you could integrate this into a lot of different applications. Now, the other thing that we can do here is we can do more than just invoke it, via passing a payload in. We can also invoke it as a web service because it's got that trigger built in. And so if you look at this here, notice how this trigger right there is the URL. So if I basically just copy this trigger here, and I say, basically export URL equals this, like that. I could say echo $URL. There we go. So we got this URL stepped in here. And then if I go to a curl command, I can basically curl this and do some more tricky stuff to it. So if I go back to my Cloud Shell, I can tee up this command. Let's see if we can get this working. So I'm going to curl, I'm going to put in the amount 134, and then in terms of the actual URL, I'll just do this. I'll just say trigger, I'll just put in the $URL, just like that, right? And in theory, this should work. There we go. So then I can actually put in, different things. I mean, I guess I could be fancy here and even like let multiple things swap, like create different variables. I mean, I guess I could try that real quick. So what I could do is I could say, open editor here, and I could first grab this command, and I could make a little edit command in here to build a invocation of this. So let's scroll this up a little bit here and make this come up here. And I could write a very simple shell command that allows me to, via terminal, new terminal, there we go. Okay, so I can just say touch invoke.sh, and then where's my invoke.sh command? Whoa, got lots of different projects open here. There we go, invoke.sh, and let's just put this inside of there and just tweak it a little bit. So basically I could do a $sign here as well, right? So I could say $sign change or something like that. There we go, change. And if I just grab this, I could say export. Actually, I think this should be in my environment already, right? Echo. Okay, so I have to go back to this terminal, which is kind of annoying, but I'll just say export $sign change equals 134 like this. Oh, I don't need a $sign right there. There we go, export. Set this variable up, echo it just to make sure it looks right. Change. Now I might have to do quotes in there like this. That looks right. And then if I put in this command like this, does that work? Uh-oh, I screwed something up. I think it's because I need to do this. I need to swap those and say these are the inner quotes are this, I believe. Anyway, well, something similar. Like getting into the bash scripting is less of the whole point here is that you can easily build out these invocations via web service, or you can invoke it via command line, and it's a great way to interact with your cloud function. So if you want to take a look at that, there's a example here that allows you to invoke this cloud function. Now there is another one that I have as well that's inside of here that I can take a look at since I have some time, that allows me to do something a little more complex, and hopefully it works. I think I'd have to look at the last invocation here. So I think there's a translation API here that I believe it's this one. That's a pretty good one. And inside of this, if we look at the source code, what it will do is a little bit more magic here. So let me just close this. So this is a good example of a slightly more complex function that I install a library called Wikipedia, and I also install a library called Google Cloud Translate. And if you look at the code here, the source code here, you'll notice that inside of this, I can actually translate whatever's passed in, and then I have a request here that allows me to pass in entity and language. So basically, what website would I like to translate, or what web page in Wikipedia, and then also what language. So I believe I can actually double check this by going back to here and going to Cloud Shell and looking at an example here. So I can say gcloud, I can say history, grep gcloud, and we can see here that there's, I think this is the one I called earlier. Let's go ahead and try this. And this would be a slightly more complex cloud function. And so it's going to ask me to do this again. So we'll go ahead and authenticate this real quick. And auth it, sure. Allow, copy, paste it in. And if I run it again here, in theory, it should look something like this. So basically, you can go through and translate. I don't know if this yeah, there we go. So you can see that in this particular function, I can pass in, names into this function, and right. So I can say, look, go to Google, go to Wikipedia, grab the Google page, grab 20 sentences and translate it to Spanish, right? And so we go here. So now Google, maybe Google doesn't match something, so we'll have to do maybe another one like Amazon. Let's try Amazon. So maybe AWS or Oracle. That's a good one. We have to find a name of a. There we go. Let's try Oracle. Yeah, so it doesn't necessarily have a ton of error handling. Well, we know one of them works. we know this one works. So and then if I wanted to change to different languages, I could just look at the different versions of languages. So I think like maybe is it Italian? Is that IT maybe? Let's see if that works. Okay, there we go. There's Italian. We could also see CN. I think is probably Chinese. No. RU is maybe Russian. Just guessing. I don't know exactly the different languages. There we go. Yeah. So